Hey students, guess what time it is? It's science time. Get out your notes and let's start learning. So let's work out some problems here, and I'm going to do a couple of these problems, and then I will have you do some of these problems on your own, and then I want you to select the correct answer, and after you select the correct answer, then you'll see how the problem is worked out. So pay attention, and one thing that might be helpful is also have that lab paper from the other day and use that as a reference. All right, so let's get started. So the first question, first example here, what is the mass in grams of 3.5 moles of copper? Now think about this. 3.5 moles of copper is like saying 3.5 dozen eggs. Okay, so if you have like 3.5 dozen eggs, how much does that weigh? So you have to know how much does 1 dozen eggs weigh in order to find this out. So let's work this one out. All right, so let's work out the first problem. Now the first thing I would recommend doing, and not so much a recommendation, just do it. Okay, this will save you a lot of issues later on, is the top of your paper, write this out. Grams, moles, number of particles. And the particles could be atoms, molecules, ions. Then at the top, 1 mole is equal to 6.022 times 10 to the 23rd particles. And in between here, we're going to put down X number of grams is equal to 1 mole. And as a little reminder here too, the place where you're going to find this information is from the periodic table. So I'm going to use PT for periodic table. Or later on, in the very near future, you're going to be using the formula weight, so FW. But right now, we're going to be using the periodic table to find out what is the value for X. So let's look at the first problem. And the first problem was, what is the mass in grams of 3.5 moles of copper? So you start with your unknown. So in this case, we have 3.5 moles of copper. It's asking, what is the mass? Now mass is measured in number of grams. So what we're going to do is start off with what's unknown. So I have 3.5 moles of copper. So you write down the number, write down the unit, and also the substance that you're dealing with. Then I'm going to go from moles to grams. So whenever you're going from here to here, this is what you're going to be sitting inside the parentheses. Same thing right here. These are also going to be set inside what's going to be inside the parentheses. You just have to figure out which over which do you have to put. So going from 3.5 moles, how many grams? So open up a set of parentheses. And remember, technically, 3.5 moles of copper is over 1. So what over here do I have to put? So what you have to do is you need to find out what value of X is. So you have to look for copper. And copper is right here. You may not be able to see it, but I would recommend getting your periodic table out. So it has a mass of 63.546 grams for every 1 mole. That's my X, 63.546. So if I want to convert moles to grams, do I put grams over mole or mole over grams? Now if I put mole over grams, let me just put real briefly here, mole over grams. If you look right here, moles is on top, moles is on top. If I did this, I would end up with a unit of moles squared per gram. And there is no such unit as a mole squared per gram. So this is incorrect here. So instead, we need a unit of grams over mole. And the mass of copper is 63.546 grams. 63.546 grams for every 1 mole. So if you look right here, mole is on top, mole is on the bottom, moles will cancel out. So I'm going to get rid of this here. So I'm going to take 3.5 times 63.546. And there's my calculator. Alright, so I'm going to take 3.5 times 63.546. I get 222.411. So that's my answer here. 222.411 grams. And also, so you write the number, the unit, and what substance are you dealing with. And when you get your answer, circle, box it in. So 3.5 moles of copper would weigh 222.411 grams. Now if you kind of think about this, this is kind of like saying, 1 dozen of eggs weighs this many grams. So if you have 3.5 dozen, how much would it weigh? That's kind of what we just did here. Okay? Or, if you had the pennies, if 1 dozen pennies weighed 63.546 grams and you had 3.5 dozen, this would be how many grams it would weigh. So this is nearly identical to when we're doing the weighing out the different types of objects. So let's try the next one. All right, number 2. During the reaction, 11.9 grams of aluminum was produced. How many moles has been produced? Okay, so again, we need to find out how much does 1 mole of aluminum weigh. So if you have 11.9 grams, how many moles do we have? So let's work this one out. All right, so now, next one reads, during reaction, 11.9 grams of aluminum was produced. How many moles has been produced? So we're going from grams to moles. Okay, so I have to change my screen here because I can't always see what's going on here. Okay, here we go. So this time we're starting with 11.9 grams of aluminum. Open up a set of parentheses. Okay, so I'm going to go from grams to moles. So I'm going to go from here to here. Tell you what, I need to look at, for aluminum, aluminum is, if you can see that here, 26.982 grams. Okay, so that is my X value here. So go from grams to moles. I need to use a 26.982. So do I put grams over mole or mole over grams? Now remember, this is all over 1. So if I want to find out how many moles do I have, what I need to do is I'm going to put grams is on top, grams will need to be on the bottom over here. So that was 26.982 grams, and it's for every 1 mole. So that's 26.982, 1 mole over here. So grams will cancel out. If we work this one out, I'm going to take 11.9 and times 1 is going to give you the same number, divided by 26.982. So divided by 26.982, and you get 0.441. 0.441 moles of aluminum. So if you kind of think about this, it's kind of saying if 1 dozen eggs weighs this many grams, and you have this many grams of eggs, you're going to have less than half of the eggs present, which is what we just found out here. Alright, so let's move on. Right, how many moles are there in 3.011 times 10 to the 23rd atoms of silver? Okay, so it's like saying if you have 24 eggs, how many dozen do you have? This is kind of along those same lines here. So what we're doing is converting the number to the number of moles. So let's work this one out. All right, so now let's start with the question. 3.011 times 10 to the 23rd atoms Ag is silver. Okay, and I want to know how many moles are there. So if you look at the problem, I want to go from number of atoms to a number of moles. So this time I have to use this conversion here. Now the fact that this is silver does not matter because I'm not going to grams. So I'm only dealing with this part, which we already have the information over here. So I'll go up to set of parentheses. Okay. Now, again, remember, this is over 1. Now, 1 mole is equal to 6.022 times 10 to the 23rd. And in this case, the particles is atoms. So I want the atoms to cancel out. So I have atoms on top, I need atoms on the bottom. So I'm going to put 6.022 times 10 to the 23rd atoms on the bottom. This way atoms will cancel out. And the unit we have on top is equal to 1 mole. So 1 mole is equal to 6.022 times 10 to the 23rd. So atoms are canceled, and we'll be left with the unit moles. So what I'm going to do, is flip this over to scientific notation here. And this is where you want to look for the EE or the EXP. Now, if you have like something like an iPhone, your EE is right here. Okay. So the way I have to put this in, okay, let me see. I have to adjust my screen a little bit so I can see what I'm doing. Okay. So I need to put in 3.011 times 10 to the 23rd. So I'm going to go 3.011. Remember, you don't hit times. Instead, you hit the EE and then 23. And then times 1, which is going to give me the same number, divided by, and if you notice up here, 3.011 E23, the E in this case is, they use lowercase e. If you have capital E, lowercase e basically means the same thing. 23 means 3.011 times 10 to the 23rd, which is what we want. So divided by 6.022, hit the exponent, 23, and we get a big old number of 0.5 moles of silver. Now, think about that for a second. Okay, 1 mole is equal to this number here. And that's just like saying 1 mole is equal to 12. This number here is half the size of this. Okay, so it's kind of saying 1 dozen is equal to 12. What happens if you have 6 eggs? You would have half a dozen. So basically it's the same thing here. So if you have 1 mole is equal to this, if I have this many, which is half the value of this, I'm going to have half a mole of silver. All it is just how many groups do I have? So it's like saying I have a half a dozen. Or in this case, I have a half a mole. All right, so let's move on to the next one here. Number 4. How many atoms are in 2 moles of sulfur? So it's kind of like, now this one's a little bit, if you think about it, it kind of makes sense here. It's kind of like saying, if you have 2 dozen eggs, how many do you have? Okay, and it doesn't matter if it's eggs, if you have 2 dozen donuts, if you have 2 dozen cars, if you have 2 dozen people, it's going to be coming up to be the same thing. So in this case, if you have 2 moles of sulfur, it doesn't matter because it could be 2 moles of sulfur, it could be 2 moles of hydrogen, anything. It'll still both be the same number. Alright, so the next question is, number 4, how many atoms are in 2 moles of sulfur? So again, start with what's given to you. You have 2 moles of sulfur. And we want to know how many atoms are there. So all we're doing here is we're going from moles to the number of atoms, or number of particles. So open up a set of parentheses. So you go from moles to number of atoms. I want to use this conversion up here. So which over which do I have to put? So keep in mind, this is over 1. So what you have to do here is moles to atoms. Moles is on top, so I need moles on the bottom. I'll put 1 mole on the bottom, and then Avogadro's number on top. 6.022 times 10 to the 23rd atoms. Moles are going to cancel. So, if we do this, take your, if you have an iPhone, just flip it up onto its side. So in order to go from 2 moles, sorry for the flickering from the ceiling fan here, I start with 2 times, and we'll be multiplying by Avogadro's number. So 6.022 times 10, so you have the EE, 23, equals, which comes out to be 1.2044 times 10 to 24 atoms of sulfur. So there's your answer. So 2 moles of sulfur would weigh, would have a number of this number here. Now if you look at this number here, this number is twice as big as this number. It's kind of like saying, if you have 2 dozen eggs, you're going to have 24 eggs. Well, 1 dozen is equal to 12. So if you have 2 dozen, you're going to have twice as many, so you're going to have 24. So this is kind of similar to that type of situation here. Alright, let's move on to the next problem. Number 5. What is the mass of 7.5 times 10 to 15 atoms of nickel? So this time we're going from number of atoms to the mass, which is measured in grams. So we're going from atoms, so we need to go from atoms to moles, moles to grams. So let's work this one out. So start with what's given to you, 7.5 times 10 to the 15 atoms of nickel. Okay. So starting from this, I'm going to go from atoms to moles, and then moles to grams. Okay, so first step, going from atoms to moles. I want to use this as my first conversion unit. So open up a set of parentheses, and then technically this is over 1. So in order to cancel out atoms needs to be on the bottom. So 6.022 times 10 to the 23rd atoms on the bottom, 1 mole on top. This way atoms will cancel out. So let's go and work this one out. So the first part is 7.5 EE 15, and I'm going to divide it by 6.022 EE 23. And you get a really small number here, because this number of atoms in comparison to a mole is a very small quantity. So this is 1.245 times 10 to the, let's count over here, 1, 2, 3, 4, 5, 6, 7, 8. And I'll get to the negative 8 moles of nickel. So not that much. So the next step, so we have how many moles we have. So we're right here on the flow chart. Next step is go from moles to grams. So I'm going to take 1.245 times 10 to the negative 8 moles of nickel and find out how many grams do I have. So this is the part where I have to go from moles to grams. I need to use the information from the periodic table to find my X value. So if you look at the periodic table, nickel is right here, okay, and that's 58.69 grams. So that's my X, 58.69. So that is my grams here. I have moles over here. So moles is on the top, so I need 1 mole on the bottom, and 58.69 grams on top. Moles will cancel. And so I'm going to do, I already had the answer from the last time. If not, just retype this in. And then I'm going to be multiplying by 58.69. So times 58.69. And I get still a pretty small number. About 7.309 times 10 to the, count over here, sorry for the glare, 1, 2, 3, 4, 5, 6, 7. So that's to the negative 7 grams of nickel. Alright, so what we just did is if you have this many atoms of nickel, this is how much it would weigh. So not by much. Number 6. How many atoms are in 4 grams of sulfur? So this time we're working backwards. So we're going from grams, and we're trying to find out how many atoms are there. So if I have 4 grams of sulfur, so if you look at the flow chart, going from grams to moles, and moles in this case to the number of atoms. Okay, so if I have 4 grams of sulfur, in order to go from here to here, I need to look at the periodic table to find my X value. So sulfur is over here. That's, if you can see that or not, that's 32.066 grams. 32.066. Alright, so this is technically over 1. Grams is on top, I need grams on the bottom. So that's 32.066 grams. And that's 1 mole on top. Grams will cancel. So I'm going to take 4 divided by 32.066 and get 0.1247. 0.1247 moles of sulfur. If you think about it, the 4 goes into 32 here about 8 times. Okay, so that's about 1/8 of the amount here. Right now, we have a number of moles of sulfur, so we're right here. We need to go to number of atoms. So in order to go from moles to atoms, I'm going to be using this next inside the parentheses. So that 0.01247 moles of sulfur. I'm going to convert that to atoms. So, again, technically this is over 1. So in order to go to the number of moles, moles is on top, I need moles on the bottom. So 1 mole goes on the bottom, and 6.022 times 10 to the 23rd atoms goes on top. This way moles will cancel out. So I'm going to take 0.1247 times 6.022 times 10 to the 23rd. So flip my phone over. You can leave it as it is. I'm going to go ahead and clear it out here. So I'm going to put 0.1247 times 6.022. Hit the EE or EXP. EE 23. So they end up being 7.509. Don't forget this part right here. Times 10 to the 22nd. That means the answer is 7.509 times 10 to the 22nd atoms of sulfur. So if you measure out 4 grams of sulfur, you're going to have 7.509 times 10 to the 22nd atoms of sulfur. Okay, so hopefully you did well on that, and eventually you're going to have a Moodle where you're going to be dealing with these type of things here. Okay, if you have any questions, just email me. Thanks. Bye. Hopefully all of you did well, and we'll be moving on here. Good job.